All right, hi everyone, thanks for coming out. Hopefully you guys are enjoying this awesome day. Today, well, first of all, my name is Grandja, and I'm on the Spring Security team, one of the core committers. And today, we're going to do an architecture deep dive on Spring Security. My number one goal today really is for you guys to walk away from this talk and understand how Spring Security works underneath the covers, because it's definitely, I mean, there's a lot of talk of magic these days, right? And magic is beautiful, no doubt, right? However, when things kind of go astray, you know, you got to have those skills to troubleshoot, right? So the more you know what's happening underneath the covers, the better you are, the more efficient you are. So that's my goal today, is to go over the core concepts within Spring Security, the core terminology, the core filters, the components, and so forth. So that's what we're going to do today. I'm going to try to keep it, I'm not going to try to go too deep because I want to be able to bring you guys back. And we're going to strictly focus on, you know, these three key areas: authentication, authorization, exception handling. Obviously, we got to authenticate with a secure system, right? We got to identify ourselves with the security system. Who am I? And what authorities do I have to access certain resources? Authorities as in, what role do I belong in? You know, role user, role admin, or finer level permissions like read, write, and so forth. Exception handling too. If I try to access a protected resource that is only administrators are allowed to access, but I'm a regular user, you know, how does that work with Spring Security and so forth? So these are the three key areas that we're going to talk about today. I'm going to do a demo first. I got a demo of a simple messaging application where registered users could send a message to each other. You could view your inbox, your sent items. Obviously, you could send messages. And then there's administration sites where you could actually view all the messages. Administrators could view them and do whatever, right? So this is these are the three users that we have registered. We have two regular users that belong to the role user, just regular users, and then an admin user that has two roles: role user and role admin. So let's jump to that demo, and we're gonna go over a few of the cases that we're gonna drill down to in the presentation with some diagrams and just kind of understand the flow that's happening. So here we go. This is an Spring Boot app. It's an Angular app. This is a public-facing site where I can log in and view my messages, send messages. So I'm going to show you this one first. So I'm going to log in as myself. I'm just a regular user. I log in. There we go. Right. So I could see my messages here. You know, my sent messages and so forth. The one thing I want to show you here, there's a lot of different ways you could authenticate with the system. HTTP basic, custom form login, you know, token based. There's a lot of different, you know, authentication strategies, right? But we can't go over them all. We're just going to go over what this sample is built with. This sample, the public facing site is HTTP basic, right? And the administration site, custom form login. Very common use cases. So we're just going to focus on that. And I want to show you here, when we authenticated, we have, I'm going to expand this a bit. And then here we have the request header, authorization base 64 encoded username and password. We're going to get into this in the diagrams to understand, you know, how the authentication gets decoded and ultimately gets authenticated with the system. I just wanted to show you that. This is how we've authenticated on the public-facing side using HTTP basic. Now, I'm logged in as Grandja, as you can see there, right? And I'm just a regular user. So what happens when I try to access the admin site? I get this 403 forbidden, right? I just got this white label page. I didn't bother printing it up or anything, but obviously I don't have access, right? So it's secured, this endpoint. Now, let's log out. We're going to log in as the administration to the administration site. And this is not Angular, this one. This is actually ThymeLeaf. And I'm going to log in here, and there we go, right? So now I could see all the users, all the message to Rob, myself, and obviously my own messages, right? So the admin user has user and admin authorities. So I should be able to also access the public site. So go to public site, and there you go. Now I'm just seeing my own messages, right? So this is a very basic example. I'm going to show. There's a GitHub repo on this. You guys could easily download this and take a look at it. But all I wanted to demonstrate here is, because this is what we're going to talk about, is the authentication and the authorization pieces, and ultimately the exception handling, how it works when we got that forbidden, right? So let's jump back to the presentation here. Okay, authentication. So authentication, I need to identify myself with the security system. Let's move through this flow. So as most of you know, and if you, actually, you know what, I wanted to gauge the audience here first before we get into this. If I could get a raise of hands, I'd really appreciate it if you did, just so I can understand where you're at with Spring Security, is who's been using Spring Security for at least 3-4 years and has used it on multiple projects? Okay, great. And how about let's say 2 years, used it on a couple of projects? Okay. And who hasn't used Spring Security and is dying to use it? All right. Okay, perfect. So we got a nice balance here. Okay, so the one thing I'm going to start off with here is this authentication filter. So Spring Security, it's all about the servlet filter. There's a bunch of filters, that are sitting in front of the actual main request handler, right? Or the main controller, if you're familiar with Spring MVC. And this is this is where all of this logic is happening. So we have the authentication filter that's sitting, close to at the beginning of the chain, which actually does the authentication. And ultimately later in the chain, there's authorization checks happening. And there's a bunch of other filters too. We can't get into all of them. We're going to focus on the authentication, authorization, exception handling filter. So that's what we're going to build on. So let's go through this flow. Assuming the request, when I was demoing there, I logged in as myself, joe@example.com. And what happens is it comes to this authentication filter. And it's built on the HP Basic authentication filter. The first thing that happens, can everyone see that okay? Yeah? Okay, great. The first thing that happens is, and as you saw there, the request header, we had that authorization header base64 encoded. First thing the HP Basic authentication filter does is it inspects the header, sees is there an authorization header, it decodes the username and password, and then ultimately creates this username password authentication token. You'll see this special stereotype above that, and we're going to get into that next slide because this is the central interface, the authentication. But for now, it's username password tokens, right? And that hence the name, username password authentication token. Creates an instance of this, populates the user and password, and then eventually passes it to the authentication manager to do the actual authentication, right? Pretty straightforward so far. We're going to dig deep down into the authentication manager right now. But before, because this is key, is what is the authentication object? It actually represents two things. When the request is coming in, before I'm even authenticated with the system, it's basically an authentication token. Consider it in the most simplest form, it's an authentication request, right? I got a username, password, and I'm going to expand this a bit because I have a feeling, how's that? Can you see the authentication there with the attributes principal? So the principal is a username, right? And then credentials is the password, obviously. Authorities, there's no authorities now because I haven't authenticated. So I don't know what authorities I have. You only know that after we've authenticated. And the flag is, obviously I'm not authenticated. These four attributes are the core attributes of the authentication object. This is authentication request. What happens after the authentication manager returns on a successful authentication. How does it look like, this authentication object? Looks like this. All right, principals, user details. This is a richer object, and we're going to dig even deeper into this. But the user details contains the principal, the credentials, encrypted credentials, and first name, last name, email address, whatever your application needs. As you saw in my demo there, I had my first name and last name on the top of the header, right? So whatever you have in your identity database, whether it's a database or another system, I just got a simple database in this case. I'm storing username, password, email, right? Pretty basic, but you could have a lot of whatever you need, right? But you'll always have these 4 attributes. But after the authentication is successful, that authentication going forward, I'm going to call it the authenticated principal. So we have authentication request, authenticated principal. It's the same object, okay? And I'm going to show you the interface here, public interface authentication, principal, credentials, and authorities. So authorities, as I was saying, could represent the role, could represent the fine or grain permission, like read, write, or however you want to structure your authorities within your application. Flexibility is there. So let's dig down. So the authentication manager gets this authentication token, right? And it calls these authentication providers. And I say providers because you could have more than one source of identity. You could have 2 different databases. One could be a database. Another one could be a remote call to another service, or possibly through an API, right? So ultimately, you want the authentication manager to call one or more authentication providers to give it an opportunity to authenticate, because you might have things spread out. But keeping things simple, we're going to assume we have one authentication provider, because we do. In this example, it's the DAO authentication provider, an implementation of this authentication provider interface. This implementation class uses a user detail service. Now, user detail service, what is that? Well, it's a service that loads user details. User details is details of a user. Like I was talking about earlier, we have principal, credentials, we have authorities, and then extra information, first name, last name, email, address, whatever your user entity is, right? So it leverages this user detail service, pretty simple interface, right? Takes in the username, which is the login name, and it returns a user details implementation. And the user details interface again here, username, password, and a collection of authorities again. And once again, this is an interface. You implement your own user details, provide extra information. On a successful authentication by the provider, because ultimately the provider is responsible for the authentication. The authentication manager delegates to these providers, asking, can you authenticate? Can you authenticate? And eventually, in this case, it's authenticated, right? Comes back, and there we go, right? The principal is now user details. When it was coming in, it was just the username, because the authentication provider ultimately creates another instance of this authentication, sets the user details on the principal, and erases the credentials, because we don't want a clear text password sitting in memory, right? And ultimately, the password that's in the user details, it's encrypted, or it better be, right? Highly recommended, right? And as you can see, it loads the authorities. Now, myself, I have the authority of a user. I'm just a regular user, right? But this is key, because this is what's used in in access decisioning later on as we step through this. Obviously, and I'm authenticated. Security context. This sometimes, on some feedback that I've been getting, is a little bit confusing. So I'm gonna try to explain it as simple as possible. Security context. It's the context of security information, right? After I authenticate, There's secure information. I'm an identity. I need to be able to store this somewhere because there might be other information that, and Spring Security is highly flexible, but right now we have a principal, but you might want to, have other security related information that you need to like group together and put somewhere, in a little package. And that's the security context. It holds security related information, right? As we're coming back that, the call stack trace there, Authentication Manager returns the authentication to the authentication filter. Now we have this authentication object that's authenticated with a principal. We need to put that somewhere because the thing is all the Spring Security filters, it relies on the authentication object and the security context. These two interfaces are the central interfaces in Spring Security. They're used by all the filters. So, and the last thing we want to do is pass security context or authentication as parameters to all these methods. So how do we get around that? We have the security context holder, which internally uses a thread local. Right? For those of you that are not familiar with thread local, it gives you the ability to store data on the current thread. Right? So obviously we have one current thread coming in, the request processing thread. I'm going to put that security context object in that thread local, so now I can access it anywhere down the chain, right? That's what the security context holder is all about. It allows all the Spring Security filters and even your application code. You could access the authentication, although that's not highly recommended either. You do want to keep. You don't want to depend on really, Spring Security APIs, and you shouldn't have to. We got these filters sitting all in front of your controllers that do all the work. But the bottom line is, it is there for you to actually get the authentication and inspect it yourself. So that's what the security context and security context holder is. And pretty simple interface, right? It gives you the ability to get the authentication. But like I was saying earlier, this is extendable. You could extend this security context implementation or interface, or your implementation of security context could store another piece of security information, maybe domain-specific stuff or network-related, whatever the requirement is.
Question.
Yes.
So if you have the security context holder sitting on your server, does that mean that you're holding some state?
Well, you know what happens, and
can you repeat the question?
Yes. The question was, if you have the security context on your server, are you storing some state? Now, the state is being stored on the current request processing thread, for sure, the authentication. But after that call comes back, when the response gets flushed out, there's another filter that I'm not going to talk about today because we can only talk about so many things, but there's a security context persistence filter that actually clears the authentication off that thread. So that way, when that thread goes back into the pool and gets reused on the next thread, there is no authentication in the thread local, right? That's how it works, right? Yeah. That answer the question? Yeah?
Yeah.
Okay. And that's pretty much it for the authentication flow, right? And just to recap, request comes into the authentication filter delegates to the authentication manager, which ultimately delegates to one or more providers to attempt the authentication. In our case, we're using the user detail service, although that's not a requirement. Authentication provider doesn't have to use the user detail service. The only responsibility of the authentication provider is to return an authentication with an authenticated principal. However it does that, right? Or if it can't authenticate it, throw an exception, right? It comes back to the filter, and then the filter sets it on the security context. That's the authentication. That's the pattern for all authentication mechanism. HTTP basic, form login, all the other authenticate. That is the pattern, right? Are there any questions before okay, yes?
So that pattern includes a thread local?
Yeah, the security context holder internally has a thread local, and that's where it holds the security context.
Okay.
Yeah.
All right.
Any other questions before we move on to authorization?
Well, I'm kind of curious, just from the talk earlier today.
Yeah.
What's going to be the impact of asynchronous?
Yeah, no, good question. Yes. The question was, as far as the talk today, specifically the reactive work that's going on, is so Rob Winch, who's the lead on Spring Security, he's working on that piece. Spring Security 5, the two big pieces there, the two big features, is Spring Security reactive support and Spring Security OAuth. Right? Although we do have Spring Security OAuth now, but we are doing a rewrite of that actually. But we won't get into that. Yeah. But yeah, no, we're going to be supporting that. Yeah. Yes.
So in most of the time, like when a request is coming, is the responsibility of the container of the server that manages the security piece. Like when it coming, it will talk to the DAP or RSA, whatever it is, and then request goes to the Spring, whatever the application is. Right? So in case of Spring, so this means container is not doing anything. Every request is going to the Spring automatically. Is the Spring framework?
No, the container ultimately. The container ultimately creates that filter chain, right? Now, your application, you're configuring filters. Now, if you're using Spring Security, one of those filters is the well-known Spring Security filter chain. But there's other filters, usually, right, that are targeted to a specific application through whether it's web XML, Java configuration, right? But ultimately the container, when the request comes in, it determines, okay, for this request, what filters do I need to apply, right? One of them will be Spring Security. It'll create this filter chain of a set of filters ordered, and then that filter chain gets invoked. Then each of those filters get applied, and eventually it hits the Spring Security filter chain. And Spring Security filter chain is a special filter. It's not just one filter. It's a filter of filters. That might be a little bit confusing, and I got a diagram at the end of this to show that. But typically, filter is a filter. It processes. Yeah.
My reason for my asking is that even the user is not authenticated.
Yeah.
It get into the application.
No.
At least
No, I'm actually gonna get to that next, right? Because the exception handling part of the presentation is the unauthenticated flow. What happens? All right, we're gonna get to that. Okay, authorization. So we're gonna jump to authorization right now. Filter security interceptor. This is one of the most, they're all important, but this is the filter that, protects your application from unsecured access. If you're not authenticated, it throws an authentication exception. If you're denied access because you don't belong, because you're not in a specific role, like myself, I can't go to the admin site. This filter security interceptor throws access denied ultimately through its collaborator. So we're going to dig into that. So authentication filter request. Authentication filter does the authentication request, now proceeds to the next filter in the chain. It's not the filter security center. This is the last one in the chain, but we're jumping ahead. Request comes in. Let's say the request is for messages inbox, right? Security metadata source. So it's metadata related to your security configuration. Now I've configured in my web security configuration, I've configured all this for this specific request pattern, messages / ***, and anything below, only role user, an authenticated principal, right, that has the role user is allowed access, all right? So the filter security interceptor has this internal list of security metadata. It matches on the current request. So the current request here we have is messages / inbox, and the pattern is messages. So that's a match, right? It matches that, and then it returns the role user, right? So that's our security data that comes back from the security metadata source. And then we get this is where the security context holder comes in again. So you be able to access the current authentication. We call the security context holder to get the authentication. And as you can see here, it's myself, role user, all right? And then these three pieces of information get passed into the access decision manager, the security metadata, the current request, and the authentication to be able to make the access decision. let's jump to that. Let's drill down to the Access Decision Manager. Once again, we have these three pieces of information coming in. In the Access Decision Manager, this is one of the core this is an interface. Same thing with the Access Decision Voter. So an Access Decision Manager collaborates with one or more Access Decision Voters. Voters decide you're going to grant access, deny access, or abstain from the actual vote, right? There's a lot of sophistication here for different access decisions. We're going to keep it simple. We're just going to talk about one of the implementations, the roll voter. It just votes on rolls, right? And as you can see, that's coming in here. The current authentication, I have the roll user. The security metadata that's coming in is allowing roll users to access this protected resource. So ultimately, the access decision voter here will send back granted, right? And this is the happy flow, right? So this returns back, and like I was talking about earlier, now Spring Security Filter, the filter security interceptor here is allowing access, and it's allowing the request to proceed now. So now the next filter, if there is another filter in the chain, goes through. If not, it ultimately hits that controller, and your business logic executes and so forth, right? So that's what happens in this case. Now, so just do a quick recap here. Filter security interceptor, three pieces of information. The security data that's security metadata that's mapped to the current request, who's allowed to access protected resource, which authorities, the current authentication, right? And obviously the current request object. It also gets the response and filter chain, but we won't get into that. And it ultimately delegates to the Access Decision Manager, its associated voters, decides whether it's granted, access, denied, or abstain. The abstain is a special case. If all voters abstain, there's some configuration. We're not going to get into that. There's a lot to go over. We're just going to keep things simple here. Before we jump into the exception handling when, you know, the not so happy cases, are there any questions on what's happening here with the filter security interceptor?
Just the voters
Yes.
seem like a tempting extension point. Like, does that make sense? Is that interface exposed for extending that, like having custom voters making custom decisions for authentication, or is that really something we should keep out of?
That is an excellent question. The question was, the access decision voter, is it an extension point? Definitely. Same with the access decision manager as well. From a really high level, there's three out-of-the-box access decision managers. You got affirmative-based, at least one voter votes yes, you're granted. Unanimous-based, all of them have to vote yes, then you're granted. And then consensus-based, majority, right? So those are the three implementation that should fit most of your use cases. However, the access decision voter, depending how you set up your security metadata, like, I mean, this is roles, that's pretty common. But you might have a very special case of how you want to set up your security metadata. And that's where the access decision voters and implementation of that understands your security metadata. All right, so that's definitely an excellent question. And in most use cases, you usually don't have to, but that's an extension point for sure, for special cases.
So if you were to come in and see someone who's extended voters, it wouldn't be like a smell, like, oh, you really shouldn't be touching it or doing that.
No, I wouldn't say that. No, I wouldn't say that. I would definitely look at the current implementations of Access Decision Manager and Access Decision Voter, see if there's something that suits your requirements, and if it doesn't, then, you know. But I haven't seen that too often. There's definitely a lot of out-of-the-box implementations there that would suit your requirements, but no, it's not a smell. I mean, if you got really special requirements, then that's an extension point. Yeah. Any other questions?
Hey, Joe.
Yes.
So the filter security interceptor, just I may have missed it, but is that a filter itself?
Yes, it is. Yeah. Yeah, that's, yeah. Yes, sorry, I keep forgetting. The question was, is the filter security interceptor, is it a filter? Yes, it is. Yeah.
or like from the system perspective, if there is a soap request or FTP client request. So this is the same filter that will come into picture, or there is separate?
No, same filters. Yeah. The data that's in the response body, right, whether it's SOAP or JSON or doesn't really matter, right? The key piece of information here is the authentication. I've already authenticated, right, and I have the authorities there, and then the metadata, the web security metadata that we configure in web security configure adapter. You know, the request patterns. For this request pattern, role admin, role user, or fully authenticated, and so forth, right? So let's jump to exception handling, the cases where I'm not authenticated or I'm not authorized to access a protected resource. So access denied. Let's talk about that first. And I demonstrated that when I logged in as myself, role user, and then I tried to type in /admin, try to go to the admin site, and we got 403 forbidden. What happens underneath the covers there? And we have another filter, the exception translation filter. This filter is always sitting in front or behind, however you want to look at it, but you know, the request flows there. Exception translation filter, all it really does is move the request forward, but it wraps itself in a try-catch block, because its sole responsibility is to catch exceptions from the filter security interceptor. Unauthenticated, access denied exceptions. Ultimately translate the exception to determine what flow is it going to go. Is it going to start the authentication process, or access, I'm already authenticated, access denied 403, right? That's literally the sole responsibility of exception translation filter. So as we, yes?
By the time you get to the filter security interceptor, isn't the credential already validated? Like you're basically checking the authorization over there, right?
Yeah, no, but at the same time, like I was saying earlier, there's the authentication manager can have one or more providers, and it tries to ask the providers, can you authenticate, right? It's possible that none of them authenticated. Not to like, okay, I'm going to backtrack. Let's say I try to, access, protected resource without authenticating, right? So the authentication filter doesn't have a basic authorization header. There's nothing there, so the basic authentication filter doesn't do anything, right? Because there is no authorization header. So it proceeds. Now I'm authenticated, right? So ultimately, the filter security interceptor, it needs to check, is there a current authentication, right? Because it's possible that I haven't authenticated at this point. Does that answer the question?
It handles both authentication and authorization.
Yeah, unauthenticated flows and authorization. Yes, and I'm actually going to go through those flows right now. So let's go through the use case. I logged in with role user, and I try to access the admin site, admin/messages. My current authentication, role user. The security metadata is different here, right? Because the request URL is admin messages, and my web security configuration that I've configured is for request pattern /admin/** only allow role admin, right? So once again, Access Decision Manager gets all these three pieces of information, and then it's denied, right? Because there's no match, right? I'm role user, only role admin is allowed in. Access Decision Manager throws this access denied exception, and this is where the exception translator filter catches that exception, and it determines, okay, is this access denied? Like I'm authenticated, but I'm not allowed access to this protected resource. This is that flow, and we're going to talk about the unauthenticated flow next. And the exception translation filter has this access denied handler. Got the interface down here. It takes in the request, the response, and the exception. This is another one of those plug-in points. Coming from a bank, you probably would want to implement your own access denied handler that does some strict security logging, so you could ultimately audit this information at a later point, right? So that would be your typical use case. The default implementation of the access denied handler, it simply just returns 403 status, as we saw there with the white label page 403. So that's the case where I'm unauthorized. Now, let's go through the case where I'm not authenticated, I'm trying to access a protected resource. So once again, we got this, we're trying to access messages inbox, just public facing site. I haven't authenticated, I've literally went into the URL and typed messages inbox, right? I'm not authenticated. As you can see, anonymous user. Security metadata, same, role user. We progress down, access to manager, voter denies, and this is the difference here. It still throws an access denied exception, right? And actually, I'm jumping ahead there. And then the exception translator filter, and that's why it's called exception translation filter, because it translates different types of exceptions and navigates the flow. This flow is different. I'm unauthenticated. So what happens here is it delegates to this authentication entry point, another core interface. And the interface is right here. We have this commence methods, similar to the access denied handler, takes in the request, the response, and the exception. And because we have HTTP basic configured for our login, the associated authentication entry point implementation is the HTTP basic. And it simply returns 401 unauthorized with the www-authenticate header.
Is that a misprint? It says access denied exception.
Well, no. It is an access denied. It is an access denied exception actually, and it translates it. Yeah, sorry. and it actually translates it because it determines there's a check in there: is anonymous user or is.
One of the voters is an authenticated. Is authenticated.
There is, yeah. Yeah, there definitely is one of those voters. This example, I'm just kind of driving on the role voter, right? But given the fact that anonymous user, it does that check, it throws this, and then it commences the authentication process, which the authentication entry point, the implementation of that starts that. In this case, sets the response header as per HTTP basic protocol, and then you get your pop-up box. You didn't see the pop-up box here because I got Angular handling 401, and then it just loads the client-side template there. With the admin site, what happens is, it's a form-based login, and what happens, the implementation of the authentication entry point, it does a redirect, sends it back a 302 redirect to the login page. So let's do a recap here of the exception handling. So if I'm not authorized, the exception translation filter delegates to the access denied handler. By default, the default implementation out of the box sends 403. If I'm not authenticated for HTTP basic login configuration that we have set up, it sends back a 401 and then a www authenticate. Are there any questions on the exception handling scenarios?
The authentication entry point is like, just so I understand.
Yeah.
It's like that's the guy who's going to decide to tell the client what he should do to be authenticated.
Yeah. The question was: is the authentication entry point? Is that what is going to instruct the client how to initiate the authentication process? Yeah, that's totally correct. It's literally like it's the entry point to the authentication process.
Would this also be involved, like we try to do things like for REST, for instance, if you need to change your password because your password is expired,
Yeah.
right? So what we have done is say that that's you are like you have an authentication problem, right, or like an authorization problem, and then send back to the client that they need to authenticate with a different scheme, which
Yeah.
is to change your password or whatever. Would this be involved in like all exceptions so that I could make those kinds of
You could do whatever you want, right? Because this authentication entry point interface, if I could just get to it, you got the request, you got the response, you got the exception. You could literally do anything you want with the response,
The
right?
default is actually a chain, so it tries a number in order until it finds one that it likes. So you can probably actually arrange it.
No, I was just curious if this guy was invoked like on any exception, not just like access denied?
No, the authentication entry point is only invoked when you're unauthenticated and you're trying to access a protected resource.
So if we have
Right.
somebody who is authenticated but needs to authenticate with a different scheme to perform another action, we can't do it in this entry point.
No.
You'd use an access denied handler. So if you're doing two-factor auth, for instance, that's normally what you do. You send a 403 or maybe a 302 to get to the next factor, that kind of thing.
Yeah. We got 5 minutes.
Different extension point.
Does that answer your question?
Yeah, I understand.
If you want to talk to me after, no problem. We could, I could get into more details for sure. So, so just to recap everything, we demonstrated authentication, HTTP basic, with the public-facing site, custom form login with the administration site, tried to access the administration site when I'm authenticated as a role user, access denied, tried to access the site unauthenticated, brings me back to the authentication entry point, the login, right? That's pretty much it. We got 5 minutes, but I got this extra slide here, and well, you know what? I'll answer your question first.
Oh, thanks. It's a quick question.
Okay.
The demo here was for a web UI, web application the structures, and the scheme of it all is the same for web services, for RESTful web services.
Yeah, as a matter of fact, the public-facing site, it's an Angular app that talks to REST controllers. The administration site is a thime leaf application, right? So yeah, and I'm actually, this is actually if you wanted to take a look at the sample that this is built on, that's the URI, and you could download it, play around with it, and so forth.
Adib's talking about REST authentication in the other room.
Oh, is he? Oh, the microservice security? Yeah.
So watch that one.
I got a little bit of time, and I was hoping I would, because I want to show you this is a pretty, this could clear up a lot of things when you're playing around with let's look at this.
Make it bigger.
Yeah. Let's look at, somehow it's, okay, you know what? Okay, so this is my security configuration that you're familiar with if you're using Java configuration, right? I have app security config and then admin security config, right? I'm not going to get too much into the details of the complete configuration. I just want you guys to have a high-level view of how the Spring Security filter chain looks like the architecture of the filter of filters, right? You're familiar with Web Security Configure Adapter, right? You're extending that to provide your custom configuration. And typically, in a lot of use cases, you only have one, right? But I got two here. Now, I could have made this into one, but I want to demonstrate how this looks like underneath the covers, right? So I have app security config. Notice this one line here, HTTP ant matcher /admin, ant matcher, right? That specific configuration there says for any calls to admin /*, hit this set of filters, right? But as you can see on the top one there, it doesn't have that, right? We just get into the filter configuration. By default, it's any request, right? But the key thing to look at here is I have order 2, order 1, because the most specific matches you want first, and admin is most specific, all right? So looking at that, looking at Web Security Configure Adapter, now let's look at this diagram here. Look at this diagram, Spring Security Filter Chain, the well-known Spring Security Filter Chain. That's actually the name in the application context. The implementation class is Filter Chain Proxy, right? Now, this is what I've got configured, right? I have two security filter chains, another core interface. And a security filter interchain matches on a request. And as you can see, the request pattern, ****, basic authentication filter. That's the public-facing site. We got 3 filters here. There's a lot more, but those are the ones we're focusing on today. And then we have the admin set of filters, request pattern admin, ***. Probably should have reversed the diagrams, because that's literally the order, right? That the filter chain proxy determines, okay, what set of security filter chains am I going to run through, right? But that's the special thing of the Spring Security filter chain. It's not one filter. It's a filter of filters. And in a lot of cases, in a complex setup, you could have 5 security filter chains with many filters in each of those chains. Right? So it's pretty sophisticated. But I wanted to give that, that 100-foot view of what the Spring Security filter chain looks like. Any other questions before I wrap up?
When you configure the Spring Security, so it's like using like AIM matchers and all of that other stuff, is there a possibility of actually like configuring part of the security directly on the controllers itself instead of having to ensure that my paths are correct within the configuration, ensuring that my matches are matching up to what my controller paths are and all that other stuff?
Well, okay, so the question was do you have the ability to configure, or I think correct me if I'm wrong, the question was he wants to be able to make sure that the security configuration matches with the controller handler mappings. Right? So it's funny you ask that, because in the latest release, we have this MVC matchers. Instead of ANT matchers, it's MVC matchers. So if you're using Spring MVC, right, you want to use this MVC matchers. Because there's some special cases that Spring MVC, /admin/messages actually maps to admin messages /.html. There's deviations of that pattern, right? So yeah, look into the MVC matchers, or we could talk about that more after too. Yeah.
You could also use method level security, actually, if you want
Yeah.
to access rules.
Yeah, there's definitely a lot more. Like we got method level security for your services, but you could even get more finer grain and have domain object security, but that's like another 2 talks. Today I was literally just focusing on the web layer, right? Before it even hits the controller. But Spring Security conforms to defense in depth, right? As in web layer, security layer, domain object access layer, right? But like I said, we could keep going on and on about that, and I think I'm up. Yeah. Thank you very much for coming out, everyone.